All right, so the question now with this one is, what do we do to get the perimeter with this first guy, A, off the study guide? And it's a fair question of how do you get it when you don't have the given diagonals. The easy ones to get are going to be things like this one right here. That's 1 unit. This guy up here, he's easy to get. That's 1, 2, 3, 4, 5 units. This side, that's not too bad to get. 1, 2, 3, 4 units. And along the bottom, I've got 3 units. All right, that's not too bad. The question now is, what do I do with those diagonals? Well, let me try and draw something on here and see if that helps. For approaching that, let's take this one over here. I know that this length is 3. This length here is 2. And that's a right angle. Any ideas how I get that diagonal that cuts across? Pythagorean theorem. I can say that 2 squared plus 3 squared is going to equal c squared. So a little bit of maneuvering here. 4 plus 9 equals c squared. C is the square root of 13, which is pretty darn close to 3.6. And so that's going to give me the length of this diagonal right here. And because of the fact that I keep reusing 2 by 3, that also tells me that. And it also over here, again using 2 by 3, this guy is 3.6. So when I go to get the perimeter, I can just add all those up now. But the key was, in order to get a slanted measurement, I have to use the Pythagorean theorem to get the length of that slant. You could also, if you wanted to, because this is on an axis, you could figure out that point, you could figure out that point, and plug them into the distance formula. I advise against that because it's a lot of extra work compared to what we're already comfortable with, which is drawing a right triangle, taking the 2 sides, and plug them in the Pythagorean theorem. So when I go to do the perimeter for this problem, I can say, well, the perimeter, I'm going to work my way around starting here. It's going to be 3.6 plus 4 plus 3. That is 4, right? Or did I miscount? 1, 2, 3. Wait. 1, 2, 3, 4. Good. 4. Plus 3 plus 3 plus 3.6 plus 3.6. Again, oh, don't forget that plus 1, and then plus 5. So I go all the way around there. So I have the 3.6, and then the 4, and then the 3, and then the 3.6, and the 1, and the 3.6, and the 5. I missed one? Okay. That's what the biggest problem with these guys is just making sure your bookkeeping is up to date. Add those all up, and you should get an answer of 23.8. That's what I have. Hopefully that's right.
Do you add the 2 or not?
What 2? No. This 2 over here. So you're looking at this 2 here? That 2 is just me marking off this triangle over here that I drew. When I go to it, let me highlight the actual figures measurements. So I did 3.6 here first. Then I came down here and did the 4, then the 3, then 3.6, then 1. 3.6 again, and then the 5. And I have to do the same kind of thing very quick. I won't do the whole problem right now, but if you take a look over here with B, when I go to do the perimeter in B, I'm going to have to find the length of this slant. And that's a Pythagorean theorem problem again. This is a problem where I'm going to be going over 1, down 4, and using those 2 numbers and the Pythagorean theorem to get, let's see, 1 square root of 17, which is pretty close to, I don't have that decimal in front of me. And again, repeat that process all the way around the figure. It's not, I don't think it's overly challenging. I think it's just a lot of grunt work. It's a lot of using stuff we've done and not getting the answer quickly. You have to kind of just keep banging away at stuff that you know you can find until it all kind of comes together. What can I say about these? Now that you kind of saw the trick with the Pythagorean theorem for getting the perimeter.